Section 4.5, Inequalities involving quadratic functions. A quadratic inequality is an inequality that can be written in the form ax squared plus bx plus c is greater than 0. Note that the inequality symbol may instead be greater than or equal to, less than or equal to. All right, so that statement just basically told you what a quadratic inequality is, okay? So first of all, notice it's gonna have an inequality symbol, okay? So not an equal sign. Instead, you're gonna have one of the four inequality symbols, okay? Since we're working with inequalities, it's a good time to make sure you remember which one is which. If you have this particular symbol, it is greater than. If you have this one, it is greater than or equal to. If you have this one, it is less than. And then if you have this one, it is less than or equal to. Okay, so you're going to have an inequality symbol instead of an equal sign. And you can write the inequality in this format. Ax squared plus bx plus c is greater than 0. Okay, and of course, it doesn't have to be the greater than symbol. It could be one of the other three inequality symbols. Okay, now keep in mind that when you are given a quadratic inequality, it may not look exactly like this, meaning one side may not be 0. Okay, but the key here is that when you scan the entire inequality, the highest power of x that you see in the whole thing is the second power. If you were to move everything to one side and combine like terms, you could make your inequality look like this. Okay, so what we're going to do in this section is we're going to talk about how you need to solve a quadratic inequality. In section 4.3, we learned about quadratic functions, and the major focus there was learning about how to graph a quadratic function based on its attributes. Okay, so there are different methods of solving quadratic functions, quadratic inequalities. We're going to focus on the method that uses the graph of the quadratic function. Okay, so if you think back to 4.3, when we covered that section and we did examples 1 through 4, each one of those examples had a part C associated with it. And in that part C, we took the quadratic function that we were working with in that particular example, and I gave it to you as a quadratic inequality. And we talked about how we would solve that since we already had the graph of the parabola at our disposal. Okay, so again, you will be using what you learned in section 4.3 to solve quadratic inequalities. Okay, so underneath the definition of quadratic inequality, I have the steps for solving a quadratic inequality graphically. Okay, that's basically, we discussed a lot of this in section 4.3, so I am going to skip this for now. Okay, once we get through the examples here, this is a really good summary of what we do to solve quadratic inequalities. So like I said, once we get through the last example, I'll come back and read through this. Okay, this is very mathy. Again, if we take a look at the examples, this will make more sense if we read through it after doing the examples. Okay, so let's go ahead and jump to example 1. Okay, and you see 4 inequalities here in parts A through D. You also see a picture of a parabola. Notice there is no formula here. There's no equation. There's no inequality. All you have is this picture of a parabola, and you've got these 4 inequalities that you need to solve, and each one involves something called f of x. Well, that is the parabola. Okay, we don't have the formula for the parabola. We're just told that it is f of x. We don't need to know the formula for the parabola to do this. Okay, so just keep that in mind when you do these, when you solve these quadratic inequalities, you just need the graph. Okay. All right, so example 1 says use the figure to solve each inequality. Okay. So in part A, it says, where is f of x greater than 0? Okay. So remember, how do you write down an answer? Okay. Your answer is going to be x values. Okay. So answers for all of these are going to be x values. Okay, so basically when you look at part A here, what you need to remember is that f of x is the same thing as y. Okay, so part A is asking where are the y values bigger than 0? Okay, where do we have positive y values? Okay, so let me write that out to the side. Okay, so this is asking nothing more than where are there positive y values? Okay, where are there positive y values? Okay, so let's go to the picture. I am going to highlight in yellow where there are positive y values. Okay, positive y values occur above the x-axis. Okay, so I'm going to highlight the portion of the parabola above the x-axis. Okay, so that's what's corresponding to this particular inequality. Okay, the portion of the parabola above the x-axis. Okay, so let me go out to the side and jot this down. Okay, there are positive x values above the x-axis. Okay, so again, this inequality in part A is corresponding to the yellow portion of the parabola that I have shaded, the portion above the x-axis. To write down the answer, you have to write down the x values that correspond to this yellow part. Okay, so if you notice the yellow part of the parabola, it occurs between the two x-intercepts. Okay, so if I'm drawing this red line here, okay, here's an x-intercept at -2, 0, and there's another x-intercept at 2, 0, and I'm drawing these two vertical red lines here to kind of make sure I emphasize where these x-intercepts are located and what's happening between them or on either side of them. Okay, if you look at this, the parabola is above the x-axis in between these two x-intercepts. Okay, so the answer here is going to be, we have positive y values, meaning the parabola is above the x-axis between the x values of -2 and +2. We have to use interval notation here. Why? Well, if I decide 0.2 is my favorite number in the world and that's my x value, doesn't it have a positive y value? Yes. So we have to catch all the numbers, including decimals and fractions, in between -2 and +2. So that's why you have to use interval notation. Okay, every single x value, decimals and fractions included, between -2 and +2, have a y value bigger than 0, positive y value. Okay, the question becomes, do you use parentheses or brackets for this interval? Okay, well, that depends on your inequality. Okay, it is strictly greater than here. Okay, so we need the y values to be strictly bigger than 0. Okay, so if you look at the two x-intercepts themselves, -2, 0 and 2, 0, their y coordinates are exactly 0. That's not what we want. We want the y values to be strictly bigger than 0. So we cannot include these two endpoints. Okay, that's the answer to the inequality in part A. Okay, the good news, the inequality in part B is nearly identical. Okay, we now have f of x is greater than or equal to 0. Okay, that translates to, where are the y values bigger than or equal to 0? So the only thing that has changed here is now the y values can actually equal 0. Okay, so this part right here is asking where are there positive y values or y values of 0. Okay, well, we already know we have positive y values above the x-axis, so we're still looking at the yellow portion of the parabola, but now the y values can actually equal 0. Okay, so the x values are going to be the x values that go with the yellow portion of the parabola plus the x-intercepts. Okay, so again, the yellow region occurs between x values of -2 and +2. Okay, but this time we're going to include the endpoints. We're going to include the x-intercepts because their y values actually equal 0. Okay, that's it. Moving on to part C. Okay, it's asking where is f of x less than 0. Okay, again, if you translate, f of x is y. Where are the y values less than 0? Okay, so I'll write that down here. This is asking where are there negative y values? Okay, we know from working with any graph, negative y values occur below the x-axis. Okay, so what we need to do is look at the portion of the parabola that we're interested in. We're interested in the portion of the parabola that has negative y values, so that means the portion of the parabola that is below the x-axis. Okay, so that's going to be this part and this part. Okay, so the part that I'm highlighting in green. Okay, so to write down the answer, we need to write down the x values over which this is occurring. Okay, now keep in mind the parabola goes down forever. Okay, so that affects your x values. Okay, so let's start with this particular side, the left side here that's highlighted in green. Okay, so we have negative y values. Any dot highlighted in green here has a negative y coordinate. Okay, we just need to write down the x values over which this is happening. Okay, well, it's happening to the left of the x-intercept -2, 0. Okay, so it's happening over all of these x values. Okay, so basically we need to write down all of the negative x values, and we get stopped at this first x-intercept, which has an x value of -2. Okay, that is that first region. Remember, if you're at -3.5, if that's your x value, -3.5 has a negative y value. Okay, so that is an x value you're looking at. Okay, so this first interval is how you write down this left green segment. Okay, it happens over x values less than -2. Okay, now do you include -2 itself? Okay, well, again, it depends on your inequality symbol. Okay, strictly less than 0, your y value can't actually equal 0 there. Any x-intercept is going to have a y value of 0, so we're not going to include the x-intercept here. Okay, we also have to write down the rightmost green segment. Okay, what x values does this green segment occur over? Well, it starts at the rightmost x-intercept. It starts when x is 2. And then after this green segment corresponds to x values bigger than +2. Okay, so we'll go off to infinity. Remember, if you're out at x equals 100, it's going to have a negative y value way down here. Okay, so you need every x value bigger than 2. Okay, you don't want to include 2 itself because 2 is an x-intercept and it has a y value of exactly 0. So we put a parentheses. It's both of these intervals together, so you can put a little union symbol there, and that's your answer. Any x value less than -2 or any x value bigger than 2 will have a negative y value. Okay, moving on to part D. Okay, again, very similar to part C. Okay, the only thing that has changed is that less than has turned into less than or equal to. Okay, so this is asking where are there negative y values or 0 y values. Okay, so again, if we're looking for negative y values, that's where the parabola is below the x-axis, so it is the green segments. Okay, so the only question is, the only thing that's changed, because of the less than or equal to, the y values can actually equal 0. Okay, so we're going to take our same answer from part C and we're going to include the -2 and the +2 because they are x-intercepts. Their y value is 0, and so those 2 points fit the bill. Okay, and that's it. Okay, that's what we're going to do when we solve these quadratic inequalities. Okay, the key is coming up with a sketch of the graph, the sketch of the parabola, and then just based on your inequality, you have to figure out if you're looking above the x-axis or if you're looking below the x-axis or even on the x-axis, and you have to write the corresponding x values that make the statement true.